I will start with, hopefully you can see this screen, which is the slide presentation, what's new in ZOS OpenSSH V2R4. Start with some legal stuff, trademarks. And then this is just a little bit about us. I noticed that most of the people registered and on the webinar are customers of Cozy, so you probably know about us. But for any others, we've had this Cozy processing toolkit out in the market since what, 2007 or 8 or something, and it relies on ZOS OpenSSH. So it relies on it for the low-level secure transport layer. So when you use Cozy SFTP, you know, underneath the covers, we're starting up an SSH secure connection and configuring it for use by SFTP. Similarly, if you use hybrid batch or ZOS remote services, that we had this remote services thing, remote data set pipes, that all uses SSH underneath. So we use SSH all the time. We really like it, and we're happy to be able to, you know, give you this update on what's coming out new. A lot of good stuff. And some of you may also know that earlier, about, I don't know, 15 years ago, we developed this product called JZOS, which was acquired by IBM, is now part of the ZOS Java SDK. Okay, so here's the agenda for today. I'm going to do just a real high-level overview of what SSH is. Then we're going to review not only the new release, V2R4, that's coming out at the end of this month, but I'll also mention briefly some of the new features that are in V2R3, the current release. But then at the end, we'll go through a bunch of migration considerations for V2R4. Okay. So, what's SSH? Well, it depends on what you mean. The original product SSH, it's by the way, it stands for Secure Shell. It was originally a program developed by a researcher at University of Helsinki named Tatu Joen in 1995. So it's not new. In the early 2000s, 2001, 2002, it became so popular in the late 1990s, became so popular that by early 2000s, 2001, 2002, there was an effort to start an RFC standardization process for the protocol. That resulted in a accepted RFC in 2006. So when I'm talking about SSH, I could be talking about a particular implementation. Like in our case, we're going to be talking about OpenSSH on ZOS. But a lot of the times we're really talking about this protocol, SSH2. And SSH2 is the name of the RFC version of the protocol. Okay, so what's an SSH2? What are the features of it? Primarily, what it has is these three things at the bottom, right? It's a secure encrypted connection over, and here's kind of, this is different from, you look at FTP. It's one single socket between a client and a server. That connection is authenticated mutually. In other words, when you connect, the client authenticates that the server is who he says he is, and then the user, the client, uses his credentials to authenticate with the server, mutual authentication. And then you can optionally, at the transport layer, you can have LZ compression at the low-level packet layer, right? So the next thing it has, sort of a layer up, if you will, is this thing, which is really cool, which is that you can, it has a multiplexing support where you can have one or more simultaneous channels, application channels, over that connection. So what's a channel? Well, there's different kinds. You can have a terminal channel, like what they call a shell channel, or you can have a remote command channel. You can execute a remote command and redirect the input and output. You can have SFTP, which is called a subsystem channel, or you can have port forwarding channels, and you can do these at the same time on the same connection if you want. It's a very, if you look at the architecture in these RFCs, it's a very well architected, layered architecture approach. So looking at the bottom, there are many compatible implementations, and because the architecture is done well and the design is done well, you don't see really hardly any problems with one implementation not being compatible with another, which is really nice. By far, the most popular implementation is what we have on ZOS, which is OpenSSH. And OpenSSH, as you're probably aware, is a default package on all of your Unix Linux distributions. It's the software that's used to log in remotely over a network as a terminal into Unix Linux. Okay. It's also available, by the way, now from Microsoft. Microsoft has ported OpenSSH for PowerShell, which is pretty cool. And that's fairly recent. PuTTY, a lot of people use PuTTY. It's a very popular free Windows client, OpenSSH client. And then PuTTY has a terminal part, which is called PuTTY, and they have a command line SFTP client, which is called PSFTP. Okay, so that's kind of a high level. Let's look at SSH2 RFC crypto from a really high level. So the first thing you think about is when you start out an SSH connection is what SSH refers to as key exchange. Now, if you're familiar with TLS or SSL, this is what they call the handshake, right? And key exchange is part of a TLS handshake. Now, SSH has an analogous thing, but it's different in terms of the details, right? The high level function is pretty much the same. It's basically uses some variant of a Diffie-Hellman algorithm so that the server and the client can exchange a mutually known symmetric cipher key that's going to be used to encrypt the connection. It generates this key and allows both ends to know it without sending it over the wire for a third party to see it. It's kind of neat. That's what Diffie-Hellman is. So that's key exchange. But as with SSL, TLS, the other thing that happens during key exchange is, let me grab a thing here, that allows the client to authenticate the identity of the server. So as part of key exchange, the server uses its public-private key pair to create a signature that's part of the key exchange. The client generates, by the way, a random number, which he knows. So those two secrets allow them to cooperate and get this mutually shared key. Okay, so that's key exchange. After key exchange, then we have a secure connection, but the user still hasn't authenticated with the server. So the user authentication is after key exchange, the user uses an authentication method, and there's several, but typically it's a password or a user key pair, and that's used to authenticate the user's credentials to the server. And for most SSH implementations, the server actually creates a new logged in process under that user's identity. And that process is what will now own the connection, right? So that's after authentication, you get a logged in user typically after authentication. And session encryption is just goes on after key exchange. This is where the shared session key that we got from key exchange is used on a packet by packet level to encrypt the packets using a cipher algorithm. And then each packet with SSH is also gets a checksum, if you will, using an HMAC algorithm, a secure MAC algorithm, which is typically something like HMAC SHA-1 or SHA-2. It's used to create a hash of each packet. So each packet is encrypted with a cipher, and each packet gets a hash. and I'm locked up. Okay, there we go. Here's a high level, very high level diagram of what we just talked about. Now, I want to point out that these arrows aren't message level. This is very abstract. This is just at a very high abstract level. This is not the actual message flows. But you start in by the client starting a connection, and at the very beginning, before you actually get into key exchange. Key exchange is this blue bar here, right? That's key exchange. Before you get into that, there's this hello exchange where the server sends this text string that says, okay, I'm SSH protocol 2, and I'm running OpenSSH, and it usually says what version. If you're not running OpenSSH, it'll put some other string in it, like I'm running PuTTY or I'm running something else, right? And they exchange that. And then they also exchange some algorithms. They negotiate what algorithms are you going to use for everything, for key exchange, for ciphers, for public keys, for user authentication. All that stuff gets negotiated. But then, once that is exchanged, then we go into key exchange. That's this blue bar. And that's where the server uses its public-private key pair, and the client does this Diffie-Hellman dance. And coming out of key exchange, we have an encrypted session. So notice that this red part down here, this is in clear text. That's not encrypted, right? It only starts ciphering, encrypting the packets after you get done with key exchange. So that's important to know. The next thing we go into is the yellow section. The yellow section is where the user still has not authenticated. The user does authentication. So he uses a public key or a password or whatever, and he authenticates. And then we're done with user authentication. And now we're into the green, right? We're into the encrypted and authenticated. That's when we're ready to go. We're ready to start doing a terminal session or an SFTP session or both or whatever, right? So one other thing I'll point out is way down here, there's this little blue bar, right? That says CAX. So what that is that's rekeying. So what happens is if you're running a session for, and you can configure this, but the default with OpenSSH is an hour or a gigabyte, whichever comes first. It will actually do a CAX just for the purposes of regenerating a new session key. Okay, that's the blue bar. I turn my spotlight off. This CAX down here is just a rekeying to generate a new session key, because I guess for security purposes, you don't want to use the same key too long, so you don't want to use it for days or something. And so every hour or gigabyte, you get a new one. Okay. All right. So hopefully that's the end of the sort of a high level view of what SSH is. Now we're going to get into talking about IBM z/OS OpenSSH. So you might be aware, or you might not be aware, that the term the product name IBM z/OS OpenSSH first appeared in z/OS V2R4, right? You're probably aware that a lot of you would be aware that before that it was called Ported Tools OpenSSH for z/OS, right? It was a separately ordered program product that was on V2R1 and earlier, right? But in V2R2, what happened was they renamed it, and it became a base element in the operating system. This FMID became a base element. So when you install z/OS V2R2 or V2R3 or V2R4, OpenSSH is a base element that you get. And on V2R2, it was OpenSSH based on 6.4. V2R3 came along. It was just a different FMID, and it was OpenSSH 6.4 also. And then V2R4 is coming out now. It's going to be this FMID, it's 2240, and it's going to be based on OpenSSH 7.6. And we'll go over into that a lot. So this is sort of the lay of the landscape in terms of the products. In this slide, I'm going to just review briefly the new functions that were brought out in V2R3, the currently available release. First of all, CPAC-F support. this is with this APAR introduced. It wasn't an initial release; it was an APAR, a PTF, and it enables the product to directly use CPACF instructions, depending on what's present, what machine you have, what level, what cipher you're using, to implement the symmetric ciphers and MAC algorithms. And prior to this, if you wanted to use CPACF, the only way to do it was to configure OpenSSH to use ICSF for ciphers and MACs. Now, that did not require a card, a crypto card. It still stepped on top of the CPACF instructions, but you went through ICSF to do it. So what this support did, you ask, well, why even bother? What this does is you don't have to go through ICSF. It just goes directly to the CPACF instructions. And it turns out that because of the frequency of those calls, in other words, you're doing a cipher and a MAC on every packet, because of the frequency of those calls, there's a significant amount of overhead in going through ICSF. So going right to the CPACF instructions actually is cheaper in terms of CPU and more throughput. So that was that. That's pretty neat. The other part of this is really neat is that you don't have to configure ICSF. You don't have to do the configuration. It just automatically does this by default with a default sample configuration. And you don't have to go in and enable some RACF rules to allow ICSF to use those algorithms and all. You don't have to do any of that stuff. Because, by the way, the CPACF instructions that are being used they are normal program instructions. They're not privileged instructions. Okay. So that you really want to use because it saves some CPU, like 20%, right? Well, maybe I'm exaggerating. Maybe 15, right? Something like that. Okay, Xert support. Do you know what Xert is? Xert is part of ZOS Com server. It was introduced in V2R4, Xert, and it's a thing where different products that do encryption can register as Xert providers, and they can provide Xert with information on their connections and what encryption algorithms they're using. And OpenSSH, as with V2R4, will talk to Xert if it's running. It'll check out and it'll talk to Xert if it's running, and then it'll send Xert all the information about what encryption protocols are using and what connections are being used, so that you can use Xert to audit your encryption from one place. You can audit your HTTPS and your OpenSSH and whatever else is using your ATTLS and everything else that's using encryption. You can do it from Xert. And then Com server cuts SMF records to do that. So it's a little easier to have him do it because he's already running privilege and everything. So this is a nice thing to do.
Kirk, we have a question.
Yes.
This is from Sandra. And the question is, do you know if in V2 version 2.4 will OpenSSH report that it's version 7. I think she means 7.6, or will it continue to report 6.4? This is a vulnerability reporting issue for us. We know it's patched, but IBM still reports the older version in its banners.
Right. Yes, I'll show you that it does. It does in its sign-on banner report OpenSSH 7.6. The hello message is what you're talking about, because some of these tools, they just connect and see what version it reports, and that's how they do. That's the extent of their certification testing. So it does. It'll report OpenSSH 7.6 when you connect to it in the hello message.
Okay, great. Thank you.
I'm going to talk a little bit more about that too. Okay, so I'm moving along. This is a high-level summary of the features in V2R4. I'm just going to skim across these, and we'll go more in depth on these items. Skimming across, it's upgraded from 6.4 to 7.6. And there's a lot to talk about there. The other thing is that if you're putting your SSH keys in key rings, let me give you using key rings. It will use systems SSL for the signature operations, and I'll talk about why that's good, and also some possible migration issues. You can put it now supports putting elliptic curve DSA keys in key rings. These new crypto algorithms are really a part of the OpenSSH 7.6 upgrade. We'll go through those. And there's some ancillary things here. There's a SSH proxy C command that IBM includes now that allows you to use it with the SSH client to navigate through SOC 5 proxy servers, right? Now, I don't know if anyone knows, we probably have some people using this of our customers. This is something that we had done in the mail available on our website, the same command, the same name, and it turns out that IBM's got something that we gave them. This is something we gave IBM to include with OpenSSH. The last thing is that IBM enhanced these SMF records cut by OpenSSH. 94 and 95 are the connection started. One is the client, one's the server. And they enhanced these because previously they were missing the remote IP address and port. Okay. It turns out I had to flip this thing off to get back to turn the page. All right. So diving a little bit deeper into this, this is going to address Sandra's question a little bit too, I think. It's upgraded from 6.4 to 7.6, okay? And it will report 7.6. However, the security patches have been ported back from as much as 7.8. So they went as far as 7.8 and ported back security patches. Now, that is a moving target, right? Because IBM does monitor security patches. They do monitor certs, security alerts, and they do patch the product to respond to those alerts. And the way you find out about those, don't shoot the messenger. This is how IBM does it. You subscribe to the ZOS security porthole, and then you will get notifications when there are things that you should know about that need maintenance that you should have. Okay, that's how that works. So unfortunately, they could have patches that fix things, but then the product still is going to report 7.6, even though they have included patches for certs, right? And you'll have some very naive security product that's testing to see, oh, well, it says 7.6, but there's this cert that's not fixed until 7.9, right? So there's a problem here with this system. Well, there may or may not be, right? IBM may have fixed that, but that's just the way it works, unfortunately. Okay, the next thing is keyring key. So this is really cool. If you put SSH keys, you've always been able to put, or for a long time, been able to put your SSH keys into a SAF RACF keyring. But before, the product would basically just pull the key material out, and then would just use its own software algorithms to do the asymmetric key operations. Okay. Now, it didn't really matter too much from a performance point of view because that just happens during key exchange, right? Or user authentication. It's not going on all the time, right? That's not a big deal. But the big problem is what you couldn't do before is you couldn't have your private key material in a card, right? You couldn't put it on a token on a card, because if you had it on a token on a card, then the software can't get the key material, which is kind of like the whole point, right? So now, because it does this, it uses systems SSL and that uses ICSF. You can have your private key material on a card and it'll work. So if you have really sensitive keys and you don't want to put them in the RACF database, right? You want to put them on a card. it'll work, whereas it didn't work before. Now, decided that the consequence of this is that since it's using systems SSL and ICSF to do these operations, you may have to enable certain RACF rules, SAF RACF rules in the CSF serve class. And that's documented in the migration thing. We'll go into that later. But if you're doing this, you might have to enable those rules, and I'll show you what they are later. Now, most people won't, but I'm going to go into that later. The next thing is that this is new. You can put elliptic curve DSA keys, which are becoming much more and more popular, both user keys and host keys, into key rings. And by the way, when you put keys in key rings, if you're enabled for FIPS mode, then those work too. Customers, yeah. So that this tells what, basically the same reason why you'd put RSA keys in key rings is the same reason. Now you can do ECDSA keys. So now we're going to move on and we're going to talk about the new algorithms. So I'm starting off talking about the key exchange algorithms, and this is the list of the algorithm names. These are the actual names that get negotiated as the ordinal or nominal names for KEX, right? When you're trying to start a session, figuring out which key exchange algorithm you're going to use. All the ones that are in bold are new, and these come as a side effect of going up to the new version of OpenSSH 7.6. The ones with asterisks, you can enable ICSF for key exchange like you could before, and those are going to be supported with ICSF. So I'm not sure why you want to do that. It's not a big deal, but you can, right? Here's what else is new. These new Curve 25519 SHA-256 KEX algorithm. So what this is the previously in 6.4, it supported ECDH SHA-2 NIST curves, right? These ECDSA SHA-2 NIST curves, those are the U.S. National Standard Curve elliptical curves algorithms, and those were previously supported. This 25519 is a sort of an open developed curve. I think it's Daniel Bernstein, the cryptographer, did that. And these are thought to be really good, so a lot of people are wanting to support these, and now they're supported in OpenSSH. Now, I'm going to mention just one oddball thing in case you're curious. You see there's this name, and then there's the same name with @libssh.org. So when you see algorithm names in SSH, if you see them ending in @ and then a domain name, what that means is that algorithm is not part of the RFC. It's not a standard name. It's a name, it's an algorithm name introduced by some implementation. In this case, the libssh people. This is a SSH library that like curl uses. Now, in this case, there's this one and this one, the same thing. Well, they turn out this is the same algorithm. This one @libssh.org came out first, and then later it was written into an RFC, so now it has one without the light. It's the same thing. It's just an alias for the same. But when you see these @names, that's what it means. You can get a list of these from the product if you do this SSH-BigQ KEX. Okay, let's moving along. These are key algorithms. And you'll see in bold, really there's just one new key algorithm. That's this ED25519. It's the same thing. It's an elliptic curve on that same curve, that 25519 curve, only it's a key algorithm instead of a KEX algorithm, because key algorithms and KEX algorithms are kind of the same thing in terms of some of the low-level stuff. So this algorithm is added. If you'll notice in there, the asterisks show the key algorithms that are supported by ICSF and also have keyring support. You can put them in key rings. These are the elliptic curve ones, This is RSA, and DSS is DSA. Those are supported in key rings. And then the other thing I want to mention is all these ones at the top that say -cert-v01 at openssh.com. Those are kind of key algorithms, but what they really are OpenSSH certificate algorithms. Okay, so here's the deals. OpenSSH, the people who do OpenSSH, the OpenBSD people, they don't really, they think that X509 is kind of a trash heap, right? Frankly, I mean, I'm not judging, but that's what they think. So what they did was they came up with their own lightweight, secure certificate algorithm. These are certs, but they're not X509 certs. They're OpenSSH certs. So the reason why you see this at OpenSSH.com is because they're not part of an RFC. They're just OpenSSH's thing. And frankly, they're not really being used that much by anyone as far as I can tell. But that's what those are. So, okay, here are cipher algorithms. Mentioning first the pound sign means that you see the ones that have asterisk also have a pound sign, because not only can you use them if you're using ICSF turned on for those, but you can also use them with this new direct CPACF instruction support. And this is the way you want to do it. In other words, you want to take the defaults. If you take the defaults and don't turn on ICSF for ciphers, you'll get these implemented with CPACF, and it's just nothing to do. It just works at the lowest CPU cost, right? This new bold one, Cha-Cha Poly 1305, that's a new algorithm. It's becoming very popular. It's a cipher algorithm that actually combines this Cha-Cha 20 cipher with its Poly 1305 MAC. It's a combined algorithm that in one operation does a cipher and a MAC. And that's kind of neat. But what's also neat about this algorithm is that it requires a lot less CPU cycles especially on mobile devices. So it's pretty secure, and it also runs efficiently on mobile chips, right? So that's why probably it's fairly new, but it's probably in the next few years it's gonna be very, very popular. Mac algorithms, the same thing on Macs. The ones with pound sign are the ones that support direct CPACF instructions. So all you got to do is take the defaults, and if you're using all the HMAC SHA ones, then like these, but not the UMAC. All the HMAC SHA ones and SHA-2s, those are all done with CPACF or ICSF. These ones at the top are kind of another thing that's not really a new algorithm. -ETM at OpenSSH.com is not a new algorithm. What it is, it's a implementation tag that says I want to. ETM means encrypt then MAC. So by default, the spec said, the RFC says I'm going to do a MAC and then I'm going to encrypt next, right? But ETM means encrypt first and then do the MAC after that of the whole thing. So some cryptographers felt that doing it in this order is somewhat better. So OpenSSH supports these, but as you can see, it's not an RFC thing because it says at OpenSSH.com. So literally half of these algorithms on these lists are just the same thing, only -ETM, sort of saying doing in reverse order. Okay, so this is the thing we talked about, the proxy client. I'm not going to go into this much. I think that this is self-explanatory, and there's some documentation that you can look on the IBM site, or you can post to our forum if you're having trouble using it. This basically allows you to configure. In this example, we show in your SSH client configuration files how you would say, okay, for this host, when I'm going to this host, I want to go through this proxy server on this proxy server port, right? That's what this does. This is the feature that we talked about. There's a new triplet added to these SMS subtypes that puts the remote IP address and port in there for both successful and failed connections. This also somewhat addresses Sandra's question down below. Some considerations for installing this. It's, again, as I mentioned, it's a base element of ZOS V2R4. You, as with V2R3, you need to have ICSF running only for dev random. You don't have to use it for anything else, but you have to have it for dev random. But if you're on a Z14 machine or later, you can configure Unix system services so that dev random uses CPACF instructions on the Z14 that do a secure random number. So you don't need ICSF. So to say that another way, if you don't have a Z14, you must have ICSF running because you must have dev random working, because SSH needs dev random to get secure random numbers for its crypto. If you have a Z14, then you can configure that so that you don't need ICSF, because there's CPACF instructions that allow it to implement dev random out of the box without ICSF. Here's how Sandra is asking. If you type the SSH version command, you'll get this is printed out. If you want to verify what version you're running for SSH, or if this is the server SSHD, it'll print it out. When you connect to SSH server, you'll get that SSH 2.0 hello message. It'll say OpenSSH and it'll say 7.6. Okay, so we're going to get into migration considerations now. Now, I'll mention, and at the end, I list this statement of direction. There was a statement of direction from IBM back when V2R3 was announced that goes over this page and the next page. You were warned, right? Okay, so this is what they warned you about, and this is what is happening. So this first page, these are things that are no longer supported. Just, used to you could do, now you can't. And because OpenSSH 7.6 basically said no, these things are basically not secure anymore. We're dropping them, right? And thankfully, none of this stuff I don't think is going to really affect anybody. Probably, I would be surprised. So SSH protocol version 1, that's the pre-RFC thing, the ancient stuff. This was disabled before. You had to enable it before, but now you can't even turn it on. It's not even available to turn on manually. SSHD, the server, has a very nice security feature called privilege separation, where it runs separate processes. One that acts sort of as a server to the first one, and the secure one does the secure things, and it goes back and forth. It's like a split personality, so that it minimizes the code surface for secure operations. Used to be able to turn off privilege separation. Now you can't turn it off. You must run with privilege separation. But as I said, it was already turned on so that you were running with privilege separation since a long time ago, right? PAWS 1120, like a long time ago. These OpenSSH lightweight certificates, they had a early version of that in V0, and those are gone. That's not going to affect anybody, I can't imagine. This is not too big of a problem, but you can't right here. You can't turn on compression until you've authenticated, right? So in the RFC, you could basically, compression gets turned on before you authenticate. And that is a security problem because, well, it is because of the way this privilege separation works. They don't want to get into that zlib library code during that sensitive phase. So OpenSSH a long time ago enabled this extension called delayed compression negotiation. And just about everybody does it now. And it's been turned on for a long time. But if you have an SSH client that's connecting to your server and you want them to use compression, they need to support delayed compression. Otherwise, it will not negotiate compression. It won't be compressed. So it's not like it's not going to work, but it may not be compressed. I don't think this is a big deal because this is something that a lot of the implementations have done, years ago. There's some really funky old algorithms that are just being dropped. Also, RSA keys smaller than 1024 bits, which everybody knows is bad anyway. Not only shouldn't you do it, but you can't, right? Okay, so that page was the stuff you can't do. This is the page that is the stuff that by default is not enabled. By default is not enabled. So you could turn some of these things on, but by default is not enabled. So by default, you cannot log into the server with a user ID that is UID 0. That's something that they have turned off. Now you can go into the configuration SSH deconfig and turn that on if you want, but be careful, right? The support for this algorithm, this Diffie-Hellman exchange key algorithm, is not enabled by default. It's fairly old, but there are still people using it. So you in the samples you can see how to uncomment that and turn that on if you need to. There's some old Mac algorithms like MD5, for goodness sakes. MD5 is disabled by default. And also, they had some of these things called truncated algorithms, where they would take 160-bit Mac and they would truncate it to 96 bits. So, which is, I guess, if you're doing slow lines and terminal sessions where you have small packets, that makes sense. But, really, come on. So that's disabled by default. Although you can turn these on if you want, but don't think you'll need to. Support for the triple des cipher is disabled by default. Can't believe anybody thinks using triple des is a good idea these days. But also, now this is more interesting, support for DSA keys, which they call DSS. DSA keys, user and host keys. So, for a long time, you could either use RSA or DSA, right? Most people use RSA, but some people use DSA because, the government thought it was a good idea, right? I guess. So, it was more unencumbered by patents, I guess. I don't know. But these days, people realize that DSA has some vulnerabilities. So these are not enabled by default because of those vulnerabilities in DSA. They're not enabled by default. But you can see that in the sample configuration from IBM, there's a thing you can uncomment them if you have them to turn those back on. Okay. Migration considerations. This is the thing I told you about because key rings are going to use systems SSL and ICSF if and only if you have in the CSF served class, you've defined rules for these resources, right? Or either a specific or a generic rule. If you have a generic rule or a specific rule that matches those resources, then you need to grant access to them. Okay. And if you have a co-processor card, then it's going to try to use it for some operations. So if you have rules for these resources, then you need to grant access to your OpenSSH users. Now, what I'll say is I don't find that most people have defined rules for these because these are basically rules that say you can use this algorithm or you can use this algorithm. Most people just don't define those rules. If you don't define a rule that matches that resource, then the default is to allow it. So most people are going to be okay, but you probably want to check. And that's in the IBM migration considerations in their documentation as well. Something you need to be aware of is this is something you should do every release, but there's this file in samples called moduli, and these are the pre-computed group modules for group exchange. And the new group exchange, the key exchange algorithms that use group exchange, they're longer and they're bigger. So these pre-computed moduli, you want to copy this, because if you don't, it has to compute those on the fly, and it takes like forever, right? So if you find yourself connecting and using one of those new group exchanges and you haven't copied this moduli file, it'll take like a minute to connect, right? Because it's like doing all this grinding, right? So you want to do this from the samples, copy the samples to that. I mentioned this, and this is how you do it in the SSHD or SSH config files. You can, or in a user-specific one, if it's on the client for just one user client, you can turn that back on just by saying public accepted key types or host key algorithms, these two things. You want to turn on plus, meaning add this back in, plus SSH DSS. Okay, so in the open source product, they changed the default for this option, use DNS. Use DNS is in the server. This is SSHD. In the server, they made it so that it doesn't use the DNS to look up to reverse look up client IP addresses. It does not do that, which is usually what you want, because you don't want to do that. It takes a lot of time, and DNS servers can hang on you, so you don't want to do that. But it also means that in the server, in your config files, you can't use domain names for match rules on processing rules, right? So that's something. So this is something you want to read. By default, in the samples and IBM samples, this is turned back on by default for compatibility. But you may want to, if you're not using match rules in your config, you probably want to disable this. It'll probably avoid hangups in cases where reverse lookups are not going very well. Okay, so here's where we get down to the migration, sort of meat of what you want to do. So this is kind of two ways of looking at it. You want to start by looking at your existing configuration files. These are the ones I list up here, these starting here. You want to look at that, and you want to see what you've changed or uncommented from the defaults, because that'll tell you what your site has changed from the defaults, and that's good information to know. You want to save copies of what you have before you go in and use the new stuff, and then you'll want to step by step. You'll want to make sure you do this thing we talked about, the moduli. And then you want to compare your configuration files to the new samples, right? Compare what you're using, not only to what you uncommented and changed, but you want to compare what yours is using to the new samples to see what's different. And that's where you're going to want to do a little research and say, well, why do I have this, and why is this sample doing it? That's when you're going to read about it and do a little bit more. Pay attention to the uncommented options in the current ones and the ones that have changed or obsolete in the samples. Make the changes and test, right? This is the reference for looking at the configure options. Under the section OpenSSH files, it goes through all the configuration options in the manual. I don't think it's too difficult, but for sites that have done a lot, I mean, we just don't find that most people change them too much from the default. So, but if you have, you probably know why you have, and you're going to want to look at that when you're upgrading to the new version. Here's a note. I think I mentioned this. If you've configured to use ICSF for Cyphers and Macs, you probably don't want to. You probably want to turn that off and go back to the defaults and use the CPACF implementation. You're going to get probably better performance. There's a migration health check from IBM that can be used to help you out with what I was just talking about. It looks at your existing configuration. You run this on your old system. It looks at your existing configuration and tells you if you are using anything, like if you're using something that you might want to look into. I haven't seen this yet, so I don't know how good it is, but that's what it's supposed to do. Xert, you might want to use Xert to see in the connections they're using. You could, if you're really worried about this, you could look at your connections and use SMF reporting and see if you're using any algorithms that are obsolete. Probably not, but you could check if you really wanted to. Okay, you're going to want to look at, a lot of you have probably seen our guide, maybe. We have this guide called a Quick Install Guide for ZOS OpenSSH, and basically what we've done in that, it's just a few pages long, and it goes you through sort of the happy suggested path of installing and configuring OpenSSH for most customers. We've updated that for V2R4. If you have any comments or questions about that, we would welcome that on. You could post them on the on our community forum, or you could open a ticket for support customers if you have questions. Yeah, in case you don't know, we do support V2R4. We've tested with it. We're going to support it as soon as it GAs with Cozy. Here's some IBM references, some open source references in our thing. So that's the end of this, right?